Hello everybody, welcome into another lesson. So this lesson is part 2 of where we left off yesterday. This is going to be graphing systems of linear inequalities part 2. And this time we are going to have 3 and even 4 inequalities in the system. So here you have the system of inequalities with y is less than 4, x is greater than negative 3, and then y is greater than x. Much like we did yesterday when we only had 2 inequalities in the system, we're going to graph all these lines first. So y is just less than 4. That means you're going to have a dotted line going through y equals 4, which would be right about here. It's going to be dotted since it's not equal to, and which would also indicate that it's not part of your solution set. So let's draw the dotted line through y equals 4. Alright, and then we have x is greater than negative 3. Well, since it's not equal to negative 3, we'll draw a dotted line through x equals negative 3 to indicate that that's not part of your solution either. Alright, so we got the dotted line through x equals negative 3, and then we need to take care of y is greater than x. Well, again, since it's just greater than, you'll draw a dotted line through y equals negative x. So, negative 3, draw an open circle there since that's not part of your solution set. You could do the same at 0, 0, and then heck, we'll even do, why don't we do 4, 4? Draw your dotted line to connect all these points. Since y equals x is not part of your solution set, y is only greater than x. So now we've graphed all 3 lines. Now we need to shade the region that meets all 3 of these qualifications. Where y is less than 4, start there, so it's going to be below this dotted purple line. Now x is greater than negative 3. That's going to be to the right of this dotted blue line. And then y is greater than x. It would be above this dotted green line. So the area you're going to shade is going to look a lot like this. And that's the shaded region that would represent the solution set to all 3 of these criteria. And notice, the more constraints you have in the system, the less shading you have to do, which actually kind of makes it nicer. You don't have as much shading to do. Alright, let's draw this back in here. Alright, so what if we had, let's see here. We have 2x minus 3y is greater than negative 6. We have 5x minus 3y is less than 3. Then we also have x plus 3y is greater than negative 3. So we got these three systems, we got these three inequalities in the system. Let's go ahead and graph these lines. Start with 2x minus 3y is greater than negative 6. Well, since it's just greater than, you'll have a dotted line through 2x minus 3y equals negative 6, since that won't be part of your solution set. So the x-intercept there would be x at negative 3. You'll draw an open circle at negative 3, 0, since that's not part of your solution set. And then you have the y-intercept would be at positive 2. You'll draw an open circle at 0, 2. Now you can draw your dotted line to the points and through the points. Make sure we get a good dotted line here. Okay, so there's that line. Now let's deal with 5x minus 3y is less than 3. Your x-intercept would be at 3/5. And of course this line will be dotted too, since it's only less than and not part of your solution set. So your x-intercept is at 3/5, which would be right about here. Draw an open circle there. And then your y-intercept would be at 0, negative 1. Draw an open circle there, then draw your dotted line up through here. Technically, these lines would intersect somewhere, but it's probably going to be so far down the road that they almost look parallel, but that's anyway what you would have. Then you have x plus 3y is greater than negative 3. Well, again, another dotted line, since we have just greater than and no equality. So the x-intercept would be at also negative 3, another open circle. The y-intercept this time would be at negative 1. Now we can draw an open dot. We can draw an open line, dotted line through those points and form the broken line, since this is just an inequality and there's no equality with it. Alright, now again, you probably want to go ahead and convert these equations to slope-intercept form in order to know where you're shading. The top one, if you did that, you would end up getting negative 3y is greater than negative 2x minus 6. To solve for y, you'd actually end up flipping the sign around, since you divide both sides by negative 3. This would turn into y is less than 2/3 x plus 2. Now you're going to do the same with the second inequality. This would turn into negative 3y is less than negative 5x plus 3, which you solve both sides for y, divide both sides by negative 3, you'll flip the sign. This will become y is greater than 5/3 x minus 1. So yeah, technically these two lines are not parallel. It's just going to take a while for them to intersect. And then of course, solve this equation, this inequality for y, you would get 3y is greater than negative x minus 3, which would turn into y is greater than negative 1/3 x minus 1. So now we need to shade the area where y is less than 2/3 x plus 2, which would be below this purple line. That was your first line, where y is greater than 5/3 x minus 1. That's going to be above the blue line. So we know it's somewhere between the two lines, and then y is greater than negative 1/3 x minus 1, which would end up being above the green line. So here's what your solution is going to look like. Yeah, it's still a lot to shade, but not as much as we had before. Not as much as we had in yesterday's, where we were shading pretty much a whole side of the plane. And it just keeps going up and up and up. But yeah, that's what your solution would look like for the shaded region of this. So yes, these can sometimes get quite messy, but still you're going to have less to shade. The more constraints you have, the less you got to shade. I'm going to do about 6 more. I don't think this has to be quite as long as yesterday, because everyone should have the general idea how this works, but I still want to be thorough enough. Alright, so what do we got next? So we have x minus 4y is greater than 0. We have x plus y is less than or equal to 1. And then we have x plus 3y is going to be greater than negative 1. So we have 3 different inequalities in this system. So let's start with x minus 4y is greater than 0. Well, since it's just greater than, it's going to be another dotted line, because x minus 4y equals 0, that line would not be part of your solution set. So, of course, the point 0, 0 obviously will be a point. You'll draw an open circle at 0, 0, since that's not part of your solution set. Why don't we put in 4 for x? If you do that, you would end up getting y equals positive 1. So right there, you would put another open circle. Now go ahead and graph this inequality line with a dotted line, since it's not part of your solution set. Trying to make this as even Steven as possible. Alright, so there's that one. Now this time we have x plus y is less than or equal to 1. Since it has the equal to component, we're going to have a solid line, because x plus y equals 1 is part of your solution set, since it has the equal. So of course the x-intercept would occur at 1, 0, so draw a solid dot there. The y-intercept would be at 0, 1. Draw a solid dot there, then draw a solid line through those points. Alright, now we have x plus 3y is greater than negative 1. Since it's just greater than, you'll end up having a dotted line, since x plus 3y equals negative 1 will not be part of your solution set. So the x-intercept would be, of course, at negative 1, 0, so draw an open circle there. The y-intercept would end up being at negative 1/3, which would be right about there. Draw a dotted line through this. Now there's your three inequality lines graphed. Okay. Once again, convert all these into slope-intercept form so you know where you're going to shade. So to do that, get the y term by itself on the one side. You would have negative 4y is greater than negative x, which when you solve for y by itself, you got to divide both sides by negative 4. That'll end up flipping the sign. So you'd end up getting y is less than 1/4 x. All right, now your second equation, get y by itself, you would end up having y is less than or equal to negative x plus 1. And then x plus 3y is greater than negative 1. This would start out with 3y being greater than negative x minus 1, which would finally turn into y is greater than negative 1/3 x minus 1/3. So now we have these all in slope-intercept form. We can go ahead and know where we're graphing. So start with y is less than 1/4 x. That'll be below the purple dotted line. So you're somewhere down in here. And then you have y is less than or equal to negative x plus 1. That'll be below the blue line. So now you're somewhere in this vicinity. But then you have that y is greater than negative 1/3 x minus 1/3. It's above that green dotted line. You're actually just going to get a very small little nook right in there. A very small little piece is actually your solution set right here. That's literally all you get. A very, very small shaded region would meet all the criteria. Should have about 5 more, then we'll be done. All right, let me just reconnect all this here. There we go, that should do it. All right, so we have 5x minus 3y is less than or equal to 4. We even have that x plus y is less than 8. And then we have that y is greater than 3. All right, so there are your inequalities. So let's start with 5x minus 3y is less than or equal to 4. Since it has the equal to component, you will have a solid line going through 5x minus 3y equals 4, which would actually make that line part of your solution. So let's find the x-intercept. That's going to be at 4/5, 0, which would be right about there. So you'll actually draw a solid dot at 4/5, 0. Now your y-intercept would be at negative 4/3, which would be about right here. So you can go ahead and draw your solid line through there, since it's actually part of your solution set since you have the equal to component. All right, now let's go to x plus y is less than 8. Since it's just less than, it'll be a dotted line going through x plus y equals 8, because that would not be part of your solution set since there's no equality. So your x-intercept, of course, is going to be at 0, 8. Well, 8, 0 I meant. So 8, 0, you'll draw an open circle there since that's not part of your solution. Your y-intercept would then be at 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. So draw an open circle at 0, 8, then draw a dotted line between the 2 points to connect them and then through them. That'll denote that this is just simply x plus y is less than 8. All right, and then you just simply have that y is greater than 3. Well, since it's just greater than, there's no equality. Y equals 3 is not part of your solution, but you'll draw a dotted line through y equals 3. So let's go ahead and do that. All right, now we need to shade the region that meets all of the criteria. Well, first, let's convert all these to slope-intercept form. To convert the first equation, this would turn into negative 3y is less than or equal to negative 5x plus 4, which when you solve for y, you'll divide both sides by negative 3. That's actually going to end up flipping the sign. You'd have y is greater than or equal to 5/3 x minus 4/3. That was critical. And then x plus y is less than 8. Just solve for y. That would turn into y is less than negative x plus 8. And then y is greater than 3. We can leave that alone. So let's start with y is greater than or equal to 5/3 x minus 4/3. Since it's greater than, it's going to be above the purple line, so it's somewhere over in here. Now, y is less than negative x plus 8. That's going to be below the blue line, so now we've just restricted it to this area. And then y is greater than 3 would be above the green dotted line. So the area you're really going to shade is going to be all of this. And then sometimes it just works out. There's still an awful lot to shade, but not as much as when we only had 2 inequalities in the system. So that would be the shaded region that represents the solution to these inequalities. And I should have about 4 more for you. Redraw that, draw that. All right, that should do it. So let's see, x is greater than or equal to y minus 2. X plus y is less than 1. I'm sorry, greater than 1, excuse me. X plus y is greater than 1. And then x is less than 10. So we have these 3 inequalities in the system. Well, let's start with x is greater than or equal to y minus 2. So if I want to find the x-intercept, Of course, you're going to want to draw a solid line through this line because you have the equal to component. So if I want to find my x-intercept, set y equal to 0, x would equal -2. So -2, 0, we'll draw a solid dot there. Then to find my y-intercept, that would give me y equals 2, which would go right here at 0, 2. Then I'll draw a solid line to connect those points. Alright, now we got x plus y is greater than 1. Let's focus on that line. This time, since it's just greater than, we're going to draw a dotted line because that's not part of your solution since there's no equality. So the x-intercept, of course, would be at 1, 0, but you're going to draw an open circle there since that's not part of your solution. And then your y-intercept would be at 0, 1. Draw an open circle there since that's not part of your solution. Then draw a dotted line through those points. Okay, and then last but not least, we have that x is less than 10. Well, it's just less than 10, so it's going to be a dotted line going through x equals 10 since that's not part of your solution set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I found it. All right, so there's all of our lines graphed. Now, we definitely want to convert these into slope-intercept form. Well, if x is greater than or equal to y minus 2, that means that y minus 2 is less than or equal to x. So let's flip this around. Y minus 2 would be less than or equal to x, which would mean that y is less than or equal to x plus 2. Then x plus y is greater than 1. This would turn into y is greater than -x plus 1, and then x is less than 10, we'll leave that alone. So let's shade the region that meets all three criteria. Y is less than or equal to x plus 2. That's going to be below this solid purple line, so now we're somewhere down in here. Now y is less than -x plus 1. That's going to be below this blue line, so now we're somewhere down in here. And then x is less than 10. That's to the left of this green dotted line. So here is going to be the entire solution. It's going to be a big area, even with 3 constraints. But not as big as it could be if there were only 2. So this shaded area does in fact represent the region that we'd be interested in that meets all 3 of those constraints. All right, there should only be 3 more, just 3 more, and then we're done. All right. So we have x minus y is greater than or equal to 0. We have y is less than 2x. And then we have 5x plus 6y is greater than or equal to 1. So we got this system of 3 inequalities. So let's start with x minus y is greater than or equal to 0. Since you have the equal to component, it's going to be a solid line through x minus y equals 0, since that will be part of your solution set. So I think it's obvious the point 0, 0 would be part of the line. So we can draw a solid dot at 0, 0. And then, of course, 1, 1 would also be a point. And so we can draw a solid line through those 2 points. And then, yep, we have our solid line there for x minus y is greater than or equal to 0. Now, what about y is less than 2x? Since it just has the less than component, we're only going to draw a dotted line, since that would not be part of your solution. So of course 0, 0 is part of it. But if you were to pick a second point, we could pick 1, 2, draw an open circle there, since that's also not part of your solution. Then draw a dotted line through those points. Since y equals 2x itself is actually not part of your solution. And yes, those lines appear to be incredibly close together. And then, of course, you have 5x plus 6y is greater than or equal to 1. Since it has the equal to component, you're actually going to draw a solid line, since this would be part of your solution. So the x-intercept would be at 1/5, would be right there, a solid line there. Your y-intercept would be at 0, 1, 6, which would be right about there. Then just draw your dotted line and draw your solid line rather, and connect the points, because you have the equal to component. And there's your 3 inequality lines. Of course, I'm always going to say convert these to slope-intercept form. So this would turn into, the top equation would turn into negative y is greater than or equal to negative x, which would actually turn into y is less than or equal to x. Then you have y is less than 2x, which we can leave alone. And then this third equation would turn into y is greater than or equal to negative 5/6x plus 1/5. So now we need to shade the area that meets all 3 criteria. Y is less than or equal to x, that's going to be below the purple line. So we are somewhere in here below the purple line. Then you have y is less than 2x. That's actually going to be below the blue line. So now you're actually down somewhere in here. Yeah, you are down somewhere in here, actually. You still have all this, but because you're below the blue line, but it's restricted a little more. Then you have y is greater than or equal to negative 5/6x plus 1/5, which would be to the right more, past the green line. So the shaded region is going to be another doozy. So this will end up being the whole shaded region that represents the solution to this system of equations. Would be that whole shaded region right there. I got just two more, then we're done. But we kick it up a notch with these last two. Alright. Almost on there. We're on the home stretch. Down to the last two. Wasn't much for that one. Okay. I could probably reconnect that a little bit better. There we go. Alright, so we have y is greater than or equal to 0. We have x is less than or equal to 9. We have x plus y is less than 15. And then we even have that y is less than x. So now all of a sudden, we actually have four variables. Four inequalities. Well, y greater than or equal to 0 would be a solid line through y equals 0. That would be the entire x-axis anyway. That makes life easy there. Now how about x is less than or equal to 9? Since it has the equal to component, it's going to be a solid line through x equals 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, there's your solid line through x equals 9. Now x plus y is less than 15. Since it's just got the less than component, it's only going to be a dotted line since there's no equality to this. So your x-intercept, of course, would be at 15, 0. So let's find that. 10, 11, 12, 13, 14, 15. Draw an open circle there since that's not part of your solution. Your y-intercept would be at 0, 15. So 1, 2, 3, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 0, 15. Now just draw your dotted line between these 2 points and actually through them, because there's no equality, meaning that this line will actually, or nothing on this line, will be part of your solutions. And then you just have y is less than x. So since it's just less than, there's no equality, meaning it's also going to be another dotted line. So draw an open circle at 0, 0. Let's do 2, 2 for good measure. Another open circle since that's not part of your solution. Now you can just draw a dotted line through those areas. And there's actually your 4 inequality lines. Let's see. The only equation I would say we should convert to slope-intercept form would be that x plus y is less than 15. That would turn into nothing more than y is less than negative x plus 15. There we go. Now we know where we're shading. So y is greater than or equal to 0. Well, that's going to be obviously above the y equals 0 line. That's going to be in the northern half. X is less than 9. That's going to be left of this point, so now we're somewhere over in here, left of the purple line, then y is less than negative x plus 15. That's going to be below this blue line here. So now we've just restricted this even more. And then we got that y is less than x, which would be below the green dotted line. So the only area that actually meets that criteria is going to be this region right here. A very small region meets that criteria. So that shaded region meets all four criteria. That would be the solution to all four of these inequalities. And I got one more problem, then we're done. Alright, let me just reconnect this coordinate plane for one last time. And that should do it. Let's see. So we have that y is less than 5. So y is less than 5. We have that y is greater than negative 6. We have that 2x plus y is greater than or equal to negative 1. Then we have that y is less than or equal to x plus 3. So we have 4 inequalities again in this system. Well, let's start with the first one. Y is less than 5. Since it's just less than, you're going to draw a dotted line through y equals 5, since that's not part of your solution set. So draw your dotted line through y equals 5. Alright, and then you have that y is greater than negative 6. Since it's just greater, there's no equal component, so that will not be part of your solution. So you'll draw a dotted line through y equals negative 6. So 1, 2, 3, 4, 5, 6. That's going to go right there. All right. Now, we have here 2x plus y is greater than or equal to negative 1. Since you have the equal to component, it will be a solid line through the line 2x plus y equals negative 1. So your x-intercept would be at negative 1/2, 0. So draw a dot there, a solid dot at negative 1/2, 0. Your y-intercept would be at negative 1, 0. Draw a solid dot there. Then draw a solid line to connect those points. And there's your line there. Then you have y is less than or equal to x plus 3. Well, since you have the equal to component, you will have a solid line through y equals x plus 3. So of course you could put x at 0, giving you a y-intercept of positive 3. So that's going to go right here, draw a solid dot there, and then set y equal to 0. That'd be at negative 3. Now you can draw your solid line since it's equal. First time you've probably saw me break out orange in any of the courses I've taught, really. So there is our 4 lines for inequalities. Now, impressively, the only line we need to convert to slope-intercept form would be the 2x plus y is greater than or equal to negative 1. That's simply going to turn into y is greater than or equal to negative 2x minus 1. Okay, now we know where we're going. Where do we need to shade? Start with y is less than 5. Well, the dotted line through y equals 5 is that purple line. So since it's less than 5, you'll shade below that purple line. So now that puts you down here. Next we have y is greater than negative 6. Well, since it's just greater than negative 6, it's that dotted blue line. That's going to put you in between the purple and blue line. So somewhere in here. Now we have y is greater than or equal to negative 2x plus 1, which would be your green line. It's going to be above it, so you're going to have somewhere in this region. And then you have y is less than or equal to x plus 3, which would be below the orange line. So, ladies and gentlemen, here is the shaded region that's going to be the solution. That meets all 4 criteria. It's actually still a pretty big area for having 4 constraints, but I mean, that's what the solution is. And there you have it. You have the shaded region that represents the solution to all 4 of these inequalities, graphically speaking. And that's it for this lesson. Next lesson, we're going to talk about something called linear programming, which will kind of piggyback off of this. So I hope everyone has a great night. Take care.